Oftentimes, optimization is the first thing you should be thinking of when you make this stuff, but just because it requires intimate knowledge of all the different things you're doing, we leave it for last. But it's good to have experience where, knowing that you have to have your experience always running at 90 frames per second. Now you can select here and say, always show me my FPS, but what's actually more important than your frames per second is knowing your frame per second is in how it relates to your CPU and your GPU, which are debugged in two different ways. So instead of being stat FPS, it's actually stat unit is what you should be using for debugging. So tilde stat unit. And what this does is it gives you not only the frames per second, but it tells me if I'm CPU or GPU bound. You can see right here, it's a little small on the screen, that my GPU is at 20 milliseconds, and then the game, which is the CPU, is also at about 20 milliseconds. So there's two different things. Your GPU is your shaders, and your CPU is your code, which if you're not using a lot of event ticks, you're not doing a lot of complicated math, it won't be your code. It's more than likely like polygon count, right? So we've seen how to reduce those, but let's go ahead and see how we can identify certain things inside your level. So I have a bunch of levels combined here to hopefully give us enough variance to see optimization view modes. So underneath lit, you have a couple of different view modes. I don't know if you guys have looked at them, but right here there's one that says optimization view modes, and you can see a couple of things here. I don't have that much crazy lighting, but you can see where you have crazy lighting, right? So right here, where it's white, that's a ton of lights, right? It's a really complex scene. Doesn't mean a bad thing. It's just it's identifying where we have lots of lights and where it's having to build a lot of lights. It's we can look at the complexity of that, but it's really cool, like, to be able to see these different view modes and the fact that they're kind of built into the engine for debugging. So underneath light complexity is Lightmap Density. All right. So here's where we can see if our assets have too much polygons and how they're affecting light. So what's happening here is that this is transparency. I've told you guys transparency is bad for VR, and this is really complex for it to figure out lighting because it's trying to shine through these assets. So they're denoted by being red, as in red means stop and green means go, right? So these are some ways of identifying, oh, maybe we should do something different with this translucent thing, maybe using that that dithered anti-aliasing that I showed last week, where it could be a masked material, might resolve all this, right? And then we have stationary light overlap. That's again here. This is the big no-no zone in my map. This needs to be built. I have 119 unbuilt objects. That means those are all the objects these static lights are overlapping with. If I built this lighting, this would actually be resolved. Of course, lighting build takes a little bit of a time, so I'm not going to do it here as part of the demo, but it's something for you to check. To build lighting, you should go to build, and you say build lighting only, okay? And then it has to go through a process of like shooting out photons and figuring out where everything is. So ultimately, it's not even going to be using a light. That light and the shadows from the light are actually then embedded into the textures inside the objects, and it's not even calculating it at all. Yeah. Building, baking, same thing. Building, baking, cooking. Yeah, baking is the lights. Cooking is the assets. So right now it's exporting the previous light. It's getting rid of the old crap, and then it will do. There's this little thing down here on a PC called the Swarm Agent, where you can actually watch it build the lighting and see what phase you're on. So if you think it's stuck, you can actually kind of debug it here. Cool. Right now I don't even think I have. Okay, so right now we are collecting photons as one would, Right. So you can watch the whole process of this lighting being built, and it goes through all these different stages, and you can see what the problems are. And then we get rid of those lighting needs to be built errors. One thing to keep in mind when doing lighting is you need to tell the engine, and the engine will warn you if you don't have a thing called a light mass importance object, light mass, and I do. I just need to make sure that it's actually too small for my world. Let's go back to the normal view. I need to have everything inside my world be inside of this, so they're usually very big. They usually encapsulate your entire map when you want to bake lights. So now I'm ready to bake lights. Cool. Now, if I have separate maps, I need a light mass importance volume in each of my maps that I'm baking. Right now, this one is just in one of the maps. Okay. If you are having problems with light baking and it's becoming too difficult, it becomes like a weird math problem, you can move your light to movable, just turn off shadows, because the shadows are the hardest thing to compute in real time. Okay? I'm going to cancel this light build. Let's see where I'm at. I'm already processing mappings. Nice. When you get done with your light builds, underneath the light mask settings right here, you can actually see where it's actually creating all these baked. These are the actual bakes, the atlases of the bakes, where it's applying those, overlapping those with the textures of all your assets from different angles. And those make it 6 light maps. Cool. Alright, let's go ahead and... You can actually work on your project while it's building light too, as long as you don't move the lights. Alright, great. So let's talk about some of the other ways of debugging. The easiest way to debug is to actually use the headset and look at objects. Let's see. It's not letting me do it real quick, so I'll restart real quick. And it's giving me errors about the assets to be fixed. We can get into that later, another time. Let's go ahead and restart the map real quick. And okay. Cool. Let's hit play. So we see our map. I'm going to do what I just told you guys, stat unit. And so now I see my frame rate is, I'm like doing 24 milliseconds, which is stat FPS. Let's see. I guess that means our frame rate is 24. So, what I can actually do, and I need to find an asset that's really bad. Let me go into mode where I can fly around real quick. Game mode, and take off all my pawns. Okay. Let's try again. Where's this pawn starting off? This guy. Let's turn that off. Not just fly around. And you can actually look at objects, and as you look at them, your frame rate will change. And it's actually the easiest way to identify if an object is actually not performing well, is just to look at it. And what the headset does automatically, what the game engines do, is they're automatically not rendering the things that are being seen. Right? That's called culling. Right? That's doing that for you, and therefore you know if you're looking at something and your frame rate drops, that there's something that's troubling in that viewport, and that's the easiest way to be able to identify some sort of problem you're having. It's just by looking through the headset and using it as like some sort of divining rod. So we turn off stat unit real quick. Stat unit. Just give me a stat. Okay. Cool. So yeah, I'm only getting like 45 frames per second. What will happen is if you're anywhere between 45 and 90, what will happen is your game will probably reduce you to 45 and double the frames so that you're hitting 90. So it's like, I can't get 65, I can't get above 45. It's doing that on purpose. It's called reprojecting, and it's just doubling up the frames to make it more smooth. It's trying to help you out in that way. One thing to try to do is make sure you tell the game engine that you want to target 90 frames per second. And so if you go to your project settings, you come down to maybe rendering. I'm not quite sure off the top of my head. Let's see, maybe general. There you go. So right now it's trying to smooth the frame rate. I'm going to say use a fixed rate of 90. You kind of really have to do that. Okay, so use a fixed rate of 90 in your general settings. And now when I save again, let's see what my frame rate is this time. Turn on FPS. Go. I'm getting even worse, so that's great. Let's fly around. 45. So I need to identify what's problematic, and over here was really problematic, right? I'm like 28, 29. So what I'm going to do is I'm going to do tilde again, and I'm going to type in ProfileGPU, and that spits out one frame of information about how my scene is rendering. I could drill down into this and I can see what it is. It looks like my lights need to be built. So it's like what I said. We've already kind of identified that the baking lighting would fix a lot of things. Turning off shadows would fix a lot of things. So right here, the other thing to identify is shadows are taking 10 milliseconds to render. Right? Other items. There's also some particle systems that are causing some issues as well, and I might need to reduce them, or make them, change the materials on them, or make them have a slower rate at which they're emitting, all kind of stuff. So this is the most used tool I use to actually try, besides just looking around, is spitting out a frame of this, and you can save this if you want to reference it later on. And there's all sorts of stuff that, visually I can see, it really is lights are taking the most issues, right? And so I bake the lighting, change them so they're not doing shadows, and then my resolution would be, or my frame rate would go up. Then there's a couple more views I want to look at. We also have shader complexity. So this is looking at your materials, and this is directly related to your GPU, and white is bad, right? And so this is probably what's killing me right here. This is particle system. This is the GPU simulation that's causing me problems with shaders, because it's all white right there. Green is go, right? Foliage does cause problems. If you can make it go from translucent to masked, if you can figure out how to do that, that means it's on-off versus trying to figure out the gradient of translucency to fix those things. You can also look at what's called quad overdraw, which for our intents and purposes we just called geometry, right? Again, we can see areas where we can optimize. The one thing we can't see here is that the sphere has a video that plays in it, and that's not rendering right now, so we really couldn't see that. And then anything else? Those are the main ones. It has densities and all this kind of stuff. Check them all out. There's also other kind of visualizations that are kind of fun. I was showing somebody today. Do overview. It's like a really cool way of seeing everything at once. And there's some really pretty ones. Yeah, that's under project settings. And say use a fixed frame rate of 90 frames per second. I literally could not get 90 frames per second on a project until I did that. I was like, oh, okay. I mean, just tell me I should be doing that. All right. So that's kind of it for debugging. We only have like a few seconds left. So the main thing I like to do is whenever I have a project, you have people come in, they want to sit down, like you hand them the headset, and how do you know when you start? So I always make a title sequence. I always make a loading level, right? The loading level is something there with a little bit of ambient noise, maybe a little bit of music, whatever, and it's a way for people to put on the headset and say, is it in focus? Oh, it's not in focus. Okay, let's adjust the straps. Let's adjust the interpupillary distance slider that's right here. Let's figure out how to make this experience good before I actually show you my experience, right? So it's a way of focusing, a way of just onboarding people to VR in general, and also it's just like a little bit of pregame to give them like a little bit of panache. So I like to do just the title of the piece. Here we go. Here's some text. Here's Worlds in a Wire. Let's export this as an FBX. And this loading level is what I essentially use my touch OSC controller for, is so I can start it and finish it, right? And if somebody's headset is way out of whack, I reset the orientation of the headset using my phone. If somebody leaves the experience earlier, I can always reset back to the loading level. And then I also have start, so I can move on to the experience itself. So let's go ahead and like desktop this thing. Logo. Cool. It doesn't really matter to me for right now. And so let's make one new level. Our last level together. Maps. So new level, which is called loading. And then bring in my meshes. I'm going to import from my desktop the logo. Sure, let's merge it all together. Okay. Okay. Cool. And so there's nothing on this level whatsoever. Pure blackness. 90 frames per second. All right. Great. Let's put in a camera or player start, whatever, and put it 0, 0, 0. Move it back a little bit, and then we'll bring in our logo. Rotate it 90. It has material, that's fine for me. And then let's give it a couple lights. A point light here, a point light there, right? Point light up top, whatever we want. Backlighting. Right, a little color theory. Maybe we can do a little blue here. Yeah. A little bit of orange here. Happy little tree. I made it while you guys did the break. Mm-hmm. And then the most important thing to do, and I don't know if I have it here, is we have to find a particle system to throw in here, because it's what everyone loves. Let's see if we have it. Like ambient dust. Super important to have ambient dust in there, because there it is. Because everyone likes just this. They're trying to grab it, right? So I have ambient dust. Super important to have ambient dust. All right, so I can look through my camera and see which direction it is, frame it up. It's way behind, so cool. There you go. That's how I know it's all lined up. Great. And then I just put on a space bar, right? So what's our levels? P main level blueprint. Space bar. Have I told you the space bar joke? Oh, so I was working with this guy at Framestore, and he'd never done debugging, right? He's just an asset guy, and I was like, "Oh, you should program it on spacebar." And so he right-clicked and he goes, "It's not showing me. It's not giving me this." I'm like, no, you have to type in the word spacebar, dude. It was like he was like, "Oh man, that's so embarrassing." Jack. Open level, and it's just called pmain. And in the same way that I'm doing this, when my experience ends, just automate it going back to the end level, whether it's at the end of your sequencer or on a key press, so that it automates it, right? The thing ends. People know it's over. Otherwise, like, is it over? But when it goes back to the main level, like, oh, it's done. Okay, and they hand it back to you, right? And then it's ready for the next person, right? If the seats adjust and somebody hits the tracker, you reset the headset so the orientation and position is done at the loading level, and then the whole experience will be good all the way throughout. Right, and so you have to refer back to the TouchOSC stuff. That would take too much time for me to put together right now. But you could definitely, with key presses, say input R for reset. All right, so we say R and reset orientation and position for the headset. And there's just not enough ambient dust in here. Just need lots of it. I don't see it really. Oh, ambient dust, where did you go? Yeah, that's awesome. So, here we go. Welds in a wire. For some reason the rotation's wrong. Let's see if this fixes it. Okay, so yeah. So as you see, as I look around, it's resetting it for me. This is the reset. You can even have it on event begin play on your loading level as well. And then tracking origin to floor level. Let's do that. Let's see what happens. So it's a little high. It's because I'm using a camera, not a pawn. It just needs to go down like 180 centimeters. I'm also not even working from 0, 0, 0. Good enough. Yeah, go ahead. Yeah, because I was pressing R. Cool. So there that is. So one more time. Looking at it, it's in focus. Something crazy is going on. Maybe I didn't make the camera. The camera's not player 0. Player 0. Let's see if that works now. Cool. There we are. So to a degree, I'm in the right place. It's following me around, and then I'm ready for it. It's in focus. Everything is good, and then spacebar, and here we are. The project unfolds. All right, and then you can literally just copy and paste the level blueprint. Just like copy and paste this and just put it in the other one, so you can do the same thing. R, opening the other level, going to the other level on the spacebar, right? So there's a little bit of optimization, of course. Like as I said, this is like a huge amount of engineering. There's a really important view modes. For instance, like we're talking about exporting entire scenes as one mesh. Like what happens is it culls things you're not looking at, but if your entire scene's one mesh, it can't not ever render that. Because if one part of it's visible to the headset, it has to render the entire thing, which is why you build only assets in like Maya and Sino4D, and you place the scene decorations inside, because if you had one lamp here and that lamp was connected to it, it's rendering that same lamp behind you. So everything should be modular and built up of smaller pieces, right? For all intents and purposes. So in Sino4D, this object was part of the MoGraph module, which is called MoText. And just type in, hey, I am some text. There it is. You can carry over the enter, right? And then you can center the whole thing. And then when you're done, it has to export it as geometry, so you convert to an object. And there it is. You have the material if you want. And it's ready to go. Cool. And that ties it all up together. You guys know everything about VR.